Okay, so what's the second thing that we can talk about from the video that caught your eye?
Probably about the stolen necklace problem.
Okay. Yeah, the stolen necklace problem. It's surprising that it relates to spheres.
Yeah.
Right, so let's do the example that he had that related it just to spheres. And we'll say, instead of, since I only brought one marker, I'll do stars and circles for the gems. Is that an acceptable necklace?
Yeah.
Does it meet the conditions?
Yeah, so what the stolen necklace problem is, so you have a necklace and then you have different types of jewels and you have an even number of each jewel. So in this case we have 4 stars and then 4 circles. So
Okay.
you want to split the jewels with your friend so that then the stolen necklace problem says you can do that if you have n types of jewels, you can do it in n cuts. So in this case you can do it with just 2 cuts, it looks like.
Okay, yeah, and let's see if we can figure out where those cuts would have to be.
So they're here and here.
All right, how'd you figure that out?
Well, I just saw there was 2 circles and then 2 stars right next to each other.
Okay,
So
all right, cool. Let's maybe do a second example. Maybe I'll do it this time with 1s and 2s. So give me a random pattern of 1s and 2s.
So 1, 1, 2, 2, 1, 2, 2, 1, 1, 1.
Okay, so 1, 2, 3, 4, 5, 6, 2, 3, 4. All right.
So in this case, you want to have 3 1s, and then you want to have 2 2s on in each group.
Okay.
So,
Hi, Maris.
how about there? In this case, we can just do it with 1 cut.
Oh, wow. Is that surprising?
Yeah. So,
Does that contradict what he was saying
well,
in the
it
video?
says you can do it in n or less. So.
Ah, okay. So in this case, we could do it with just 1 cut. All right, is there a way to do it with 2 cuts?
There should be. So we have here, and then we have these 2 parts in it.
Nice. Okay. Did you understand how this related to a sphere? That was probably pretty tricky, but did it make sense?
So it was saying you have your 3 parts, and then they mapped to, one was x and one was y, and one was z, then it mapped to points on the sphere.
Okay. And how did that mapping work? Like, how did he describe that sphere? Do you remember?
So I think it was the it was the unit sphere. So I think it was x squared plus y squared plus z squared equals 1.
Okay. Had you ever seen this representation of the sphere before?
No.
No, so that was new to you. Okay. That's okay. Do you believe that that's
Yeah.
that's how a sphere works?
Well, wouldn't it be less than or equal to? Because you want this stuff inside too.
Oh, that's a great point. So what do you think it means when we say equals 1?
Well, that means.
What do you think this geometric shape is when we say it equals 1?
Well, I'm kind of envisioning just being the outside of the sphere, just like hollow. It would be hollow inside.
That's right. It's sort of the boundary. This would be like a balloon, and
Yeah.
that's the surface of the balloon, except
Yeah.
how thick is that balloon?
It'll be 0 thick.
Yeah, but it's sort of the boundary. And yeah, you have a great point. If we say less than or equal to,
Then we have all the points inside.
then it's all the points inside the sphere. Yeah, and actually that makes for an interesting point to talk about. Because you were calling this a 3-dimensional sphere, and so is that what you meant with everything on the inside too?
Yeah.
It is, okay. And what makes you say that's three-dimensional?
Well, it's in like the third dimension, so it would, the sphere, that's a three-dimensional shape.
Cool. And what about when it's equal?
That would just kind of be like, that would be the boundary, but just like the hollow side, but that still would be a three-dimensional shape.
You think that's a three-dimensional shape? Okay, yeah.
Right.
Even though, like, I'm trying to reach for a blank piece of paper. Okay, so what dimension would you say this is? How many dimensions is it? Pretend it's infinitely thin.
So that's two-dimensional.
Okay, and what if I sort of bend it into a cylinder? Which I thought would be easy, but apparently wasn't.
So that's going to be a three-dimensional shape even though it's hollow inside.
Okay, so you would call this a three-dimensional shape even though it's hollow on the inside, and that's sort of like the surface of the sphere. Okay, yeah, that's interesting. Okay, well, cool. And then so it related in the video to that, and you were worried that when he said equals 1, that was just the boundary. All right, any other thoughts you had about the sphere?
Not really.
Not really? Okay, well, cool. So did you like this video?
Yeah, it was a really neat video.
Yeah, it really is a cool video. It's really fun to learn how to make videos like that, right? Yeah, I think so too. All right, hey, good job, hon.